Hi everyone, it's Darren again, and today I'm going to teach you how to solve for quadratic equations. So now a lot of you will know that if I give you the question of x plus 1 equals to 3, you would be able to tell me that x equals to 2 because you'll bring the 1 over to the right hand side. So 3 minus 1 gives us 2, so it's as simple as that. But let's say now, if we were faced with something slightly more difficult and more challenging, let's say we were given this equation, x squared minus x minus 2 equals to 0. It's not as easy, right? So allow me to explain to you how we're going to solve for these types of equations. So the first step to solve this type of equations is we have to factorize it. So we're going to factorize it, and I'm going to factorize it, and I realize it's going to be x plus 1, x minus 2. This can be found using the cross method, which I covered in another video. I'm going to factorize this quickly, and I won't show the steps because this is to save time. But if you're interested in what's the cross method, you can always please refer to my other video. Okay? This video, the point is more about how we go about solving the equation rather than how we factorize it. Okay? So now let's say we factorize this into this, and this whole chunks, both of these will be equals to 0, right? Okay, great. So after factorizing, the first step, we have gone from here to here. And now, how do we solve? Okay? We actually are very close to solving, but one important thing we must take note is that we must have something equals to 0. Okay? If this was equals to 1, we will not be close to solving. Okay? I'll explain this to you further later on. So it has to be 0, remember, and take note. So if everything on the left hand side is here and we factorize it nicely like this, and the right hand side is 0, we can use this method, which I'm about to tell you, to solve the quadratic equation. So what happens is, you have to think about this example and use this knowledge to apply it to this question and solve. So let's say if I would give you a times b equals to 0. If I told you this and this equation is true, you are able to tell me that either a or b has to be 0, or even both are 0. That is why this is true, right? Because if a is 1 million and b is 0, this will be 0. So either a or b is 0. Hold on. Let's see what happens. Isn't this pretty similar to this? Yes, it is. Why? Because if I take this whole chunk as our A and this whole chunk as our B, isn't it very similar now? Yes, it is. So with this knowledge, we're going to apply this equation into our quadratic equation here. So therefore, recall I said that either A or B has to be 0 for this to be true. Yes. Hence, what we can do is just say, for this equation to be true, either x plus 1 equals to 0 or x minus 2 equals to 0. Now, yes, this equation will have two answers. That's why there's an or. Okay? So we're going to go about solving. So this will just be x equals to -1, and this will be x equals to 2. Hence, you have your two answers here, 1 and 2. So these are your two solutions, and this will be the right answer for this quadratic equation. Now, let me explain a bit further why this does not work if it is equal to 3 or any other thing. Even if it's 0.01 or 1000, whatever it is, as long as it's not 0, it wouldn't work. Why is that? Because again, let's say I said A times B equals to 1000. Correct? Now, in this example, A can be anything and B can be anything. There's infinite possibilities of what A and B can be, such that this equation is true. It's infinite. This can be 1, this can be 2000, this can be 2, no, sorry, this can be 2000, this can be half, this can be 500, this can be 2, etc, etc, etc. And all of them make this equation true. So the special property that we are playing on is that a times b equals 0. In this case, it's special because one of them must be 0, and we are not faced with many combinations of possible answers. So we know that either one has to be 0 for this equation to be true, and we apply it to an equation that it has something like this: factorized equals to 0. Okay. So this is going to be a very basic video, as mentioned in the title. So I'm going to work on some other examples now that are also basic. So let me start off with the second example. So the second example, I'm going to give examples where we already have factorized the equation. Okay, because I do not want that to be part of this video, because I want to make it really as simple as possible. In the next advanced video, I will cover how I do the factorization, the simplification, everything, and then finally solve. Okay, but here we're just being faced with questions where they're giving us in a form where it already has been factorized nicely. So now 2x plus 3 and x minus 11 equals to 0. Okay, so it's been factorized nicely for us, and again take note, this is 0. So therefore, we can use our same knowledge previously. This can be, it's our a, this is our b, equals 0. So a times b equals 0. Either a is 0 or b is 0. So 2x plus 3 equals 0, or x minus 11 equals 0. Hence, this just gives us 2x equals to minus 3, and this gives us x equals to 11, x equals to minus 3 over 2. So we have our two answers here. Okay, great. Let's move on to our third example now. In our third example, we are faced with something slightly different. It's a bit different, right? It's no longer a bracket times something in a bracket. But what should we do here? Well, what we can do here is actually, again, we're going to apply a times b equals 0. And just that our a and b is different here. So a times b equals 0. With this logic, you know either one has to be 0. And now, what if I say our 2x is our a, and our b is 9 minus x? Exactly the same, right? It'll be in the same format. Therefore, this just gives me either 2x is equals to 0, or 9 minus x equals to 0. Hence, this is just x equals to 0, right, simply? And here will be x equals to 9. So these are our two answers. Okay, good. Let's move on. Something slightly different again. How are we going to solve? Say we have x minus 9 squared equals to 0. This may be slightly different, but recall that we can actually just expand this, correct? And this will just be x minus 9 equals to 0. And now, we have our a, we have our b, a times b equals 0. Therefore, x minus 9 equals to 0. Or x minus 9 equals 0. But now, in this case, if both of them are the same, you won't have to write the same thing twice, okay? You can just say, you can just write this once and don't have to write the or and repeat the same thing. It'll be fine. Your teachers will know about it, so they will give you the full marks if you do it as such. So now, what you can do is just x equals to 9. In fact, even this step doesn't need to be shown. This step was just for me to explain it to viewers. Actually, in your exercises and in your exams, writing it as such, based on this observation here, will be fine. You would get the full marks. Okay, great. So let me move on to our fifth example. I'm going to make it even more different, slightly more interesting. we have 3 multiplied by x plus 4 and 2x minus 6 equals to 0. This is strange, right? Slightly different from all our previous 4 examples. But when faced with a question like this, quadratic equation like this, we can actually think about this, okay? If I say 3 times a times b equals 0, again, actually, if you think logically, either a or b will have to be 0 again. So in a way, even if we have a number here, a 3, it wouldn't matter, it wouldn't affect our answer. We again can use the same thing, because this x plus 4 can be our a, this 2x minus 6 can be our b. So based on this equation, either a or b has to be 0, right, for this equation to be true. Hence, same logic applies here. For this equation to be true, either this has to be equals to 0 or this has to be equals to 0. Therefore, we can just write as such. X plus 4 equals to 0, or 2x minus 6 equals to 0. Hence, our answer will just be x equals to negative 4 and 2x equals to 6, x equals to 3. So our two answers. Okay, great. I hope you've been following along well. Here is our last and final example for this video. Say, we had an example as such. Okay, minus 4, x minus 2, x plus 2 equals 0. This time instead of a number, we have a negative. Will this actually affect what we have, affect our equation, and we have to use a different method to solve? The answer is no. We can use the same logic to solve this equation also. Why? Right? If I say minus a times b equals 0, isn't it true that either a or b will still have to be 0? Yes, simple as that. So with this logic, we can close out our final example, and again, we see that 4x minus 2 equals to 0, or x plus 2 equals to 0. So 4x equals to 2 and x equals to negative 2. Here x will just be equals to half. Hence, these are our two final answers. Okay? So I hope that you learned the basics of how to solve algebraic equations from this video. I hope they enjoyed learning from this video. And please, once again, like, subscribe and comment. Thank you very much.